the data that can improve the models has become increasingly harder to generate. I used to say, like, last year we needed Iron Man to improve the models. Now you need like the Avengers.
Welcome to Decoding AI, where we go deep with the founders, operators, and researchers shaping the future of artificial intelligence. I'm Anand Daniel, partner at Accel. Today's guest is Jonathan Siddharth, CEO and co-founder of Turing, someone from my hometown Chennai. Turing is one of the world's fastest growing AI companies. Turing has quietly become a trusted research and development partner for top AI labs and forward-looking enterprises. They're helping push the frontier in areas like reasoning, multimodality, tool use, and coding by powering critical workflows like supervised fine-tuning, reinforcement learning, model evaluation, and much more. Welcome, Jonathan. For the audience, it'll be great if you can start out with a quick background of yourself and then Turing.
My journey has been super interesting. Like, I grew up being fascinated by neural networks. Like, one of the first programs that I wrote in college was like teaching a car to drive itself by fine-tuning a neural network.
Wow, you're ahead of your time.
At the time, I thought that the term neural network was kind of cool, and I liked the biological inspiration. So I came to Stanford to do grad school specializing in AI. And when I came to Stanford, my ambition was to become a researcher, to be a research scientist in AI. At Stanford, I published papers. I received the Best Master's Thesis Award in Computer Science for my work on near-duplicate document detection. So I came to Stanford assuming I'm going to be in research.
Okay.
But at Stanford, there's this weird thing where there's this radioactive spider that crawls around the campus and kind of bites people and they become founders. That startup bit me.
Okay.
That spider bit me. And
Which year was this?
This was 2005.
Okay.
Right? Growing up in Chennai, and Chennai is amazing, and I learned so much from my journey in India. I came in with this mindset that if you had to build an iconic company like an Apple or a Microsoft or a Google, you have to obviously be at the top of your game academically, and then there is like some extra experience that you need. Maybe you go to business school, maybe you get some years of work experience before you start a company. But at Stanford, I was seeing all these students in my class who were just starting these big companies. Like, I was with like the YouTube founders when YouTube was built and acquired by Google. And it breaks that barrier. You feel like you're already ready, right? And you get that surge of, I would say, false confidence that starting like a multi-billion-dollar company is pretty easy. Of course, it's not, but you get that confidence, and that's needed, right? So that was a big part of it. And Stanford does a good job of this, where in the Gates building, like, they had the offices of Larry and Sergey that were still open at the time, and they were maintaining that. And then you get inspired. Okay, these companies like Google, YouTube were started by people no different than you. So it gives you that confidence. And then it's the talent density. Like, Stanford is where I met my co-founder, Vijay Krishnan. We took like a class together where you have to build a search engine. We both got excited by the idea.
He also got bit by the spider.
He also got bit by the spider. The spider is very active. It's very viral.
Yeah.
And that talent density, you kind of need that. You need to be surrounded by other crazy, ambitious people who like want to build things. And then we started company number one, which was Rover. It was a company that did personalized search and discovery. This was the time when I thought, me and my co-founder, we could build a company that could be bigger than Google. Turned out to not be the case. The company had a good acquisition, but it was a tough journey. It was a 9-year journey. And I learned a lot of lessons from that experience that helped me with Turing.
Okay.
So Rover was this exciting journey, ups and downs. We had like acquisition offers from Google and Twitter that we turned down and then kept going. Eventually, the company had a good acquisition, but it was a 9-year journey. It was one of those journeys that I would say like was kind of bruising in some way. I learned a lot about myself. One of the things I learned about myself is that I probably hate losing a lot more than I enjoy winning. One of the founder traits that you need is a certain level of persistence and pain tolerance, like stress tolerance. So Rover significantly increased, I would say, like my stress envelope for that moment, which today like made a lot of things at Turing quite easy. So it was not an easy journey, but it was a good acquisition at the end, and I took some time off after that to recharge.
Okay.
I was so used to like running so hard for like so long. It's so weird to even your brain has so much inertia.
Yeah.
So I had to like take a break to even figure out like what I wanted to do next.
How long was that?
I would say like about 6 months, but with various stages of activity. Like the first couple of months, maybe I was truly disconnected. But after that, like I was starting to like read up on deep learning. I wanted to catch up with like what's going on with deep learning. I was connecting with my inner AI researcher again.
Yeah.
And at the time, I almost had this thought of, should I become a VC or should I start another company, right? And that thought maybe lasted for maybe like 30 minutes.
VC, that's how much VC appealed to you. I hear you. Yeah.
I just had like these so many accumulated lessons from the Rover journey and was like itching to apply them to Turing.
Okay.
In a machine learning sense, it's like having a training set of all of these examples from Rover. Okay, I did this and this happened. I did this and this negative thing happened. I wanted to distill that. It's like a form of imitation learning for like the next startup. And it was clear that I wanted to build something again. I teamed up with my co-founder, Vijay. He felt the same thing too. So we started building Turing in like late 2017.
Okay.
And this genesis of Turing was actually an idea from our first startup, where we found it really hard to hire great software engineering talent in the Bay Area. In the Bay Area, you're constantly competing with Google, Apple, Facebook, Amazon, and a million startups for the same limited talent pool, right?
Problem continues, looks like. Yeah.
It continues, right? And
Yeah.
there are only so many people who graduate from Stanford and Berkeley.
Yeah.
And our thesis was that let's look for Silicon Valley caliber talent in places where nobody's looking, right? So Turing started with this bet that let's use AI to source, vet, match, manage the best engineers in the world. So we built the platform, grew it to millions of software engineers. At the time, we had about 3 million software engineers on the platform. And now it's 4 million. And we were growing like crazy. When COVID hit, we started growing even more because people started caring less where the talent was from as long as it was elite talent. So we built the world's largest developer cloud. And then we got this fateful call from OpenAI, where OpenAI was training GPT-3. And they wanted to teach GPT-3 to code, right? To do coding and function calling and tool use.
Which year was this?
Early 2022, I think.
Okay.
Yeah, something like that. And so they came to us because like we had the world's best software engineers. We had the largest developer cloud in the world. We partnered with them. And then ChatGPT launched. And when we partnered with them, it wasn't even clear like how big this could be. We weren't sure if this is like a research project, right? Like but we didn't think it would, or something that would kick off a revolution.
Yeah. Yeah.
But it turned out ChatGPT ignited a revolution.
Yeah.
And everybody was so amazed by how good these LLMs were at coding, right? So when some of the OpenAI team members went and started other companies or joined other labs, they always kept taking Turing with them because that was part of the secret sauce for helping the LLMs to code well.
Got it.
So then we started working with, in addition to OpenAI, with Anthropic, Meta, Google, Microsoft, NVIDIA, literally Amazon, anyone that's building a frontier model, they use us to train the models to get good at coding, STEM, math, multimodality, tool use. We've also rapidly expanded our capabilities. On one hand, while we are working with the frontier labs to fine-tune models and build agents, there's this big opportunity in the enterprise where you again have to fine-tune models and build agents to solve real workflows. So that opened up a bigger opportunity for us, and we're pursuing that in parallel to this.
You were doing something else, right? You were providing best coders to Valley companies to doing this. Like, what was the thinking process? And as you pointed out, it wasn't a big, like you didn't know how big it'll get at that time.
Yes.
Right? As an entrepreneur, there comes this time when you have to make that decision. Walk me through the decision, and also maybe a little bit on why is the training data so important? Like maybe for the people who are not as deep in it, just break it down for us as well.
with Turing, phase one for us was let's build a platform where we can find the smartest software engineers in the world. We'd done that. And we were already on a path to moving up the value chain where we don't just want to give you access to the world's best engineers. We want to solve your most important problems with them.
Okay.
So we were starting to do delivery where we are like delivering projects. We are partnering with companies on managing them and delivering real work, right? Like collaborating on projects. So OpenAI met us at the perfect time because doing evals, post-training of these LLMs to teach them to code was one type of project. And we already had the muscle for that. We're perfectly positioned for the AGI wave to hit. It's a little bit, Anand, like how NVIDIA had made GPUs and they had the best GPU infrastructure in the world. And the best use case for GPUs used to be high-end graphics for gaming. But turns out an even better use case is training large neural nets, right? So NVIDIA had the world's largest GPU cloud. We had the world's largest developer cloud, or I would say human intelligence cloud. And yes, one thing you can do is have them solve important problems. Another thing is train LLMs to utilize that collective brain power. So we built this tooling and infrastructure to have these humans very efficiently generate data to teach LLMs to code. You need innovation in different algorithms, architectures, research. Research has to keep moving forward. You need compute and you need data. Like all of these have to advance in parallel. And in some ways, research gets diffused. Like people publish results, people move around. I feel like data is where you can truly differentiate, especially if you are generating proprietary data. Because the pre-training data sets that these models are usually trained on are relatively commodity. Everybody's training on the same subset of the internet. But in post-training, you can really differentiate. As these models have gotten smarter and smarter, the floor is going up, right? In many areas, the models used to be at middle school or high school level. Now they're already at expert human level. So as the models are getting smarter and smarter, the data that can improve the models has become increasingly harder to generate, right? Because the models are advancing in depth for coding, STEM, reasoning, etc. The models are advancing in breadth for multimodality, multilinguality, multi-industry, etc. And the models are becoming agentic, where the model can execute a complex multi-step workflow in a real-world business setting. Now, what do you need in a platform that can generate data to help the models advance along depth, breadth, and the agentic dimension? You would need a platform with the world's smartest humans working together. Sometimes you might have to daisy chain different humans together to move the model. I used to say, like last year, we needed Iron Man to improve the models. Now you need like the Avengers.
Because that's a good one.
Like for example, for physics, you might need a PhD in physics who can first break the model, like see where the model is weak. But to test a theory in physics, the person might ask a question. You might need a software engineer to write a simulator to test a theory in physics. You might need a data scientist to analyze the results of the simulation. So the platform would have to orchestrate a physicist with an expert software engineer, with an expert data scientist. And this interdisciplinary team is what is needed to move the model forward. So the bar for humans is going up in terms of marginal human intelligence that can move the model forward. In the past, before I would say the reasoning models came out, the labs were okay with having, I would say, a data factory or a recruiting platform. It was the era of simple data. Like send me lots of humans or send me throw some data over a wall. Now, what the labs need is a strategic research partner that can work together with them to analyze the gaps in the model and strategically engineer custom data, build custom tools that can generate the data to move the model forward and to iterate very closely with the research team in a tight loop. So it's the era of research accelerators. So Turing is one of the world's leading research accelerators working with all of these frontier labs to advance the models forward.
And this is all towards AGI, or where are we headed here?
We are headed, I think the cool kids in the Valley now call it ASI, Artificial Superintelligence. AGI is not cool anymore. It's ASI.
Cool.
Right?
Yeah.
And that's where we are headed. I think there are 4 pillars to ASI. The 4 pillars are multimodality, reasoning, tool use, and coding. Right? And I'll explain why. Multimodality is needed so that to teach the models how to process audio, video, image, visual inputs.
Yeah.
Right? We humans, I'm talking to you, I'm reading your body language,
Yeah.
I'm reacting to you.
Yeah.
I can filter out background noise and really focus on what you're saying.
Yeah.
We need to imbue the models with that level of perception. Right? So multimodality is super important,
Okay.
both for understanding and generation. The second pillar is reasoning. And coding is also helpful here because when the models get good at coding, they also get better at reasoning. But you also want to teach the models reasoning from domains like STEM and other disciplines. The third is tool use. We humans, we climbed the intelligence ladder by mastering how to use tools, right? A human in front of a computer can use a variety of different tools. If you pick, I don't know, an AE at a sales rep at a B2B healthcare startup, that human might be using tools like LinkedIn, Salesforce, ZoomInfo. They might be using Gong. They might be using all of these different tools on a computer to get their job done. So you have to teach the model how to use tools. And finally, coding. Coding is the ultimate meta skill because if the model doesn't know what tool to use, it could code up the tool itself, right? So if you solve multimodality, reasoning, tool use, and coding, my argument is that you can solve any type of knowledge work. Pick any industry in the world. And for the engineers in the audience, I'm going to go through a nested for loop. So for every industry you can think of, retail, healthcare, life sciences, etc., for every function in that industry, software engineering, product marketing, product R&D, sales, etc., for every role in that function, let's say in marketing, you pick director of performance marketing, CMO, SEO, analyst, etc. For every workflow that a human in that role does, let's pick maybe the director of performance marketing. One workflow that human might do might be how to analyze the ROI of different marketing channels. So that human is looking at Facebook's campaign management dashboard, LinkedIn's campaign management dashboard, calculating things like customer acquisition cost, lifetime value, figuring out the yield and efficiency of a channel, the scalability of a channel. That human might be looking at NetSuite to see whether the leads that came here, how much revenue did they actually end up generating to optimize different channels. They're running A/B tests, analyzing data based on which channels are working well. They might want to make some changes in the website funnel. So what I just described touched on multimodality because you have to understand what's going on a screen. It covered reasoning to figure out how do you figure out which channel to invest more money in. Tool use, they're using all of these different tools, and coding, you're updating the website. But that the same logic applies to every cell in that 4-dimensional matrix of industry, function, role, and workflow. That is $30 trillion of knowledge work that's waiting to be automated, right? And Turing is at the thick of it because on one hand, we are helping fine-tune models and build agents for these frontier labs. And on the other hand, if you're an enterprise, if you're a Fortune 500 company, you need custom models yourself that need to be fine-tuned on your proprietary data that distills knowledge and insights from the humans working in your company and automate proprietary workflows in your business. So exactly what the work we've been doing for the frontier labs, I think enterprises will also benefit, but for proprietary data, proprietary knowledge to realize all the benefits of this.
Got it. I want to go to the enterprise in a minute, but congrats to you on getting Turing as the name. And then you also have Alan now. Maybe just talk a little bit about Alan.
As a research accelerator, we have 3 pillars.
Yeah.
We have an R&D team that which includes experts in coding, multimodality, multilinguality, STEM, etc. They work on top of 2 engines. The first engine is a talent engine, where we have these 4 million plus software engineers. We've adapted the engine to now find PhDs in physics, chemistry, math, biology, Olympiad level talent in math, in physics, in chemistry, etc. In a just-in-time fashion. If you want experts in any domain, we are now finding healthcare professionals, lawyers, a variety of different smart humans from every field. We started off by finding smart software engineers. Now we've expanded to find smart humans in every domain, growing by about 50,000 people a month.
Okay.
So that's the talent engine. Alan is our platform that the talent works on top of alongside AI to generate data. So Alan is a collection of tools for data capture, evals, custom generation of data. Alan also includes RL gyms, where we build these environments which help train enterprise agents with reinforcement learning. Alan has controls for managing talent, managing the quality of the work, using AI to assess the quality of the work. Alan is the platform that generates data for multimodality, reasoning, coding, tool use, etc. And that's really our secret sauce. It's the combination of talent and the platform. And Alan coincidentally stands for, completely a coincidence, accelerated learning of advanced networks.
Okay, yeah. Someone named someone very well.
Yes.
Long back,
Yes.
Alan Turing. Yeah, that's awesome. But then let's switch and talk about in lab settings, POCs. Great. Like, how do you get this into enterprise grade? Like, what happens? Like that bridge there.
The enterprises want to work with us
Yeah.
because we've been working with all the frontier labs in fine-tuning these very advanced models and building agents. Enterprises want the same thing, where they want to build custom fine-tuned models on top of their proprietary data, distill proprietary knowledge into these LLMs, in many cases build agentic human-in-the-loop systems to solve important business problems. Right? Enterprises want the same thing, but they have some obstacles. Like with enterprises, they ideally want a partner that knows what's coming, at least like 6 months down the line. It's very hard to predict in AI what will happen beyond 6 months. They want, many times enterprises need help with also building their data infrastructure. You'd be surprised, or maybe not surprised, like I was surprised, seeing many mission critical enterprise workflows like run on spreadsheets, right? So oftentimes the data is in silos. So we have to solidify the data infrastructure. Enterprises also care a lot about confidentiality and privacy. They don't want the data that they are generating. They don't want their data to help a competitor get better at their business, right? So we have to solve for that. We have to solve for hallucinations, safety, etc. Hallucinations, of course, will not go away. You just have to engineer around it. So our expertise in custom model fine-tuning, building agents, etc., has been helpful for these enterprises. And these enterprises are starting to see themselves differently. The AI era thinking is, I should be fine-tuning a model on my proprietary data with my proprietary knowledge to help my product win in the marketplace. And we are seeing that shift. A lot of the more advanced enterprises don't just see their job as let's just roll out a bunch of copilots and we'll call it a day. You have to do that. That's table stakes. Yes, you should be using ChatGPT or like applications like that.
Yeah.
But the next level is custom models that are fine-tuned on your proprietary data. That's how it'll give you an edge. If you're running an insurance company, you should probably be fine-tuning a model to automate underwriting. You should probably be fine-tuning a model to automate claims processing. And you should do it with the right data governance, privacy, confidentiality controls. The companies that do that will be the winners in the space. And every CEO in the Fortune 500 is wondering what the AI era means for them. So we want to help them be the most AI native company in the space. The biggest fear a CEO might have is to be out AI'd by a competitor in the thing that is their core business, right? Because it's going to be hugely disruptive. In many of these cases, Anand, I really feel like we're going to see 100x productivity gain in many cases. And we as humans cannot even fathom what 100x productivity gain means. We are so used to thinking of these LLMs as co-pilots, as something that helps me be 20% better at my job or 30% better at my job. We have to start thinking of them as agentic systems that are no longer bounded by the human. They are bounded just by compute and data. The agent version of Anand will go and do 100 times the work that you might be able to do. You're limited by space and time. It might be talking to 100 times more entrepreneurs in parallel.
Yeah.
And all that we need to solve is the same four things: multimodality, reasoning, tool use, and coding. That version of yourself could be having, 100 more interviews in parallel, just as we are talking.
Yeah, I think that's a very cool view of the world. And what's the relevance of humans in all this? Like, so, right, so because the human data and the training and all that, maybe talk a little bit of, like, can most of the things be generated, right?
Turing's mission is to unleash the world's untapped human potential.
Yeah.
In a world where every human is 100x more productive, amazing things are going to happen. I think my job will be maximally automated. 3 years from now, I think almost every type of white collar knowledge work will be automated. When that happens, when every human is 100x more productive, I'm 100x more productive, I'm, instead of running one company, maybe I'm running 100 companies. Somebody like an Elon might be running 500 companies instead of 5, right? So I think we're going to see an amplification of human output. And I'm curious, Axel might be seeing this already in their data, but my hypothesis is you're probably already seeing much smaller teams. If you segment by stage of the company, for 1 million ARR, what's the median size of the team? To hit 10 million ARR, what's the median size of the team? 100 million ARR, you're probably seeing smaller teams.
Yeah.
I think we'll probably see like $1 billion companies built by one person, $10 billion companies built by a couple of people, as you have these agentified versions of humans giving people tons and tons of leverage. It's going to be an interesting future where there'll be, I think, a lot more entrepreneurs than there are today. Now, a non-technical founder can more easily start a tech company because in many things we are intelligence constrained, right? And when you're intelligence constrained, what you would do is you would raise a lot of money and try to hire the humans to do that. Now we are distilling humanity's intelligence into these models across a variety of different domains. So there's going to be big amplification there. On the data side, the bar continues to go up. It has already gone up. I think a couple of years back, if you look at the companies in the data labeling space, they were all generating like relatively simple data, like data that a relatively inexpensive contractor would be able to contribute. Now it's really the smartest people in the world across a wide variety of domains that will be contributing data. I imagine almost every human in the world has something useful to teach a model. One interesting trend we are seeing, Anand, is the rise of reinforcement learning, right? Most of the progress in ASI today is really two technology trends, deep learning and reinforcement learning. And today what we see is a lot of demand from our clients for RL gyms to train enterprise agents. So in an RL gym, we basically create like these artificial environments. Think of it like world models for business. We create replicas of websites like Uber Eats, DoorDash, NetSuite, Salesforce, LinkedIn. We create all of these replicas of these different websites. There's one version of an RL gym, which is a GUI clone, where you are teaching a computer use agent. So we create this replica of this environment. We have human experts that create prompts or workflows and verifiers for those workflows. And all the activity is tracked in terms of the state of the environment, the data model, etc. And we Dockerize this and ship it to our clients. And there's another version of an RL gym where it's an environment designed to be operated by agents for function calling and tool use. It involves the use of a variety of different tools in a certain sequence and coming up with a response, right?
Got it. Yeah.
And reinforcement learning works really well when you can verify whether the result is correct, which works well for coding, math, and some of these STEM-like hard sciences. So I think we're going to see the rise of reinforcement learning, where the role of the human is going to change. In imitation learning, the human is asking the question and showing the answer. In reinforcement learning, the human is generating the questions and creating verifiers. Not showing the answer, but just a way to verify whether the answer is correct. We're getting into this generate, verify paradigm. That's reinforcement learning. The role of the human is super interesting because the human is creating these prompts, these verifiers, and of course humans at Turing create these RL gyms. The model is going to try out different simulations, different trials to figure out how to solve it. And as a researcher turned entrepreneur myself, like I think that's incredibly cool. It's like how Alpha Zero came up with a way to play Go just by playing against itself. Here it's kind of cool that you just give the problem, you give a way to verify it, and the model is figuring out like what tools to use in what sequence, what APIs to use in what sequence, in some cases how to write code. I think it's almost magical. And I feel like reinforcement learning is one of those magical things where there's this move 37 in Go, where the AI model that DeepMind developed came up with a move that baffled the world's best Go players. Because humans don't think that way. The move was alien in its intelligence. And reinforcement learning gives us an opportunity for the AI to come up with some alien ways to solve problems.
Yeah.
And I think that'll be really cool.
How about in the physical world? Like there's, how do you think about that? Because we've talked about a lot of the knowledge work, but let's say using robotics or even anything else in the physical domain.
I think the next frontier is going to be embodied AI and robotics. I think the physical world is also constrained by data. But I think on the algorithm side too, there's more research and work to be done. You're absolutely right that the future is going to look something like humanoid robots with like a AGI brain. And it's almost like the real world intelligence and digital intelligence are sort of evolving separately right now. I think they will merge. I see interesting companies like generating data in unique ways in the physical world. Like there are companies I've heard of where people are going around with GoPros, capturing data, doing different tasks that become good data sets to train these systems. I think we're a few years away from it actually being used in the wild. But I'm super excited about it. Like there's almost this dichotomy between consumer and enterprise, like in the robotics world. Like it seems like there's faster progress happening in an industrial setting when you're building robots inside a warehouse or inside a factory that are custom made for like very specific tasks, and they are in a much more controlled environment. I think robots doing general purpose tasks in a real world setting is still really hard, very hard. And there's some interesting questions about like whether you make them humanoid or do you make them custom for the job, right? I mean, clearly, if you look at the Optimus robots from Tesla, they're going the humanoid path. But I also see other companies like taking let's call it the Roomba path, right? Like they just custom engineer the form factor for the job to be done rather than trying to be human. Right?
Yeah.
I think it's going to be super fun. And we are not far away. I mean, I feel like we're in a year, human to AI communication will probably dwarf human to human communication. It may already be here. I'm not sure if that's not already the case, given how good voice mode is in many of these AI consumer apps.
With that, maybe just a few rapid fire questions, like
Yeah.
quick shot, whatever comes to your top of your mind. One part of the AI stack that's still mostly duct tape.
But I would say on the data side, we're still in experimentation mode. We are trying a lot of things. Some things work, some things don't work. And I think that's research, so it's fine.
Most underrated global market for technical talent right now.
Underrated would probably be parts of Africa. LATAM has really strong technical talent too, but I don't think it's underrated. I think it's rated highly.
Okay.
In India, Vijayawada, Indore, places like that, like away from the big cities.
One belief about ASI or HITL you've changed your mind on recently.
HITL, for those listening, is human in the loop.
Yeah.
What have I changed my mind on? I think what I've changed my mind on is I used to think that there has to be a research breakthrough in addition to scaling up compute and data to get to ASI. Now I'm of the view that we don't need any more research breakthroughs. Just by scaling up compute and data, I think we'll get to ASI. However, we will probably have a lot more research breakthroughs, given how many smart people are working on it across OpenAI, Anthropic, Apple, Meta, Google.
Last question. The next legendary AI company will win by mastering dash.
Enterprise data. People working across different industries in different functions. That data is much harder to obtain and costlier to obtain. Mastering that will mean the models will work well for real people doing real work. And I think that's needed.
Awesome. On that note, thank you so much. It's been an amazing conversation. Learned a lot of new things.
Great.
Really appreciate you doing it.
Great. Thank you.
Thank you. Yes.
Cool. Great.